Okay, in this video, I'll be discussing what conjugate bases are, and I'll be going through some examples. First off, let's look at this equation right here. HA is our generic acid, while water in this case is acting as a base. Water is special because it can act as a base or an acid, depending on what it's mixed with. Since we are mixing with an acid, it's going to act like a base. So what is an acid and what is a base? Well, an acid, according to Bronson and Lowry, is a proton donor, while a base is a proton acceptor. So water is our base. It's going to accept a proton from this generic acid to form hydronium. Sometimes you'll see it written as H plus as the hydrogen ion, but no, they really mean hydronium. Protons do not exist by themselves in solutions. And this A minus right here is what resulted from our acid losing its proton and formed the conjugate base. So if you want to think of it this way, the conjugate base is what has lost its proton from our acid. It's like the opposite. So our acid will form the conjugate base. Our base forms that conjugate acid. That's a quick way to think about it. So let's look at this example right here. Sulfurous acid, H2SO3 plus H2O. Keep in mind, these are all conjugate base examples, so water will always be acting as the base. So let's go back to this example. So our acid will lose a proton because acids lose protons, or donate protons if you want to say it that way, to our base. So H2SO3 will lose its proton, our hydrogen ion. So we still have another hydrogen, SO3. Keep in mind, we did not move any electrons. We still have our electrons from that hydrogen. So we only lost a positive charge from our neutral compound, our neutral molecule. So this will be a minus right here. And plus because our water accepted that hydrogen ion to form hydronium with a positive because it gained a proton, it gained a positive charge. This molecule right here lost a proton, so it gained its negative charge. So remember, our acid formed our conjugate base. So we can write right here, conjugate base, Cb, and this is our conjugate acid. Okay, next example, chloric acid. Once again, this is our acid. Acids donate protons, or a hydrogen ion. So our H from our ClO3 is gone. So we'll have ClO3. We only donated a proton. We did not move its electrons. So we'll have a minus right here because this was neutral. Plus water. But our water was the base, which gained that proton. So it's H3O. With a positive because it was neutral and it gained a proton, and protons are positively charged. So this is our conjugate base, and this is our conjugate acid. All right, hydrogen sulfide. Hydrogen sulfides are acid, so we have H2S. We'll lose one of those to form HS. We only donated the proton, so we still have those electrons, so this will be a negative. Plus H3O, hydronium, because it gained that proton. So HS minus is our conjugate base. H3O is our conjugate acid. Okay, now this compound right here, we have CH3-2OH positive. Well, which one are we going to donate? We will be donating this H right here. Okay, so when we do that, we'll still have CH3-2O. However, we lost that H, or that proton. And this molecule was originally positively charged, so we're just going to stay neutral. CH3-2O. No charge on it. We lost our positive charge, which will just go back to 0 or neutral. Can't forget our hydronium ion, so H3O positive. So this is your conjugate base, and this is your conjugate acid. So CH3, 2O. Let's look at this one. Hydrogen sulfate. So this is our acid. Acids donate protons. So we'll have SO4. Now look, we are already having a negative charge on this molecule. So when we lost a proton, we will now have a -2 because we lost another charge. So we cannot forget our hydronium, H3O positive. And this would be your conjugate base, and this would be your conjugate acid. So what is actually happening when our molecule donates a proton? Well, when I drew out this Lewis structure, it makes things much more clear. Now, as you can see, this example is the same thing from number 1, sulfuric acid being mixed with water. So we have our Lewis structure for sulfuric acid. We have H2O, and then we have the conjugate base and the conjugate acid. So what do acids do? They donate protons. So we can either take off a hydrogen ion from here or from here. Doesn't really matter. So I excised this hydrogen ion, and when we did that, we still had those electrons. We only donated the proton, so we're not removing the electrons. So when I removed this proton, it's going to be attracted to this lone pair on the water, and that is why it bonds right here. And water, if you do the formal charge on this oxygen, the hydronium ion, you will see that the positive charge lies on the oxygen. And when we remove that hydrogen ion, we found out that this oxygen has a negative because we still kept the electrons and we only donated the proton. So if we find the formal charge on this oxygen, it should be negative. So that is exactly what's happening when a acid donates a proton to its base. The proton is attracted to that lone pair. That gives that oxygen a positive charge, while this hydrogen atom did not remove its electrons. It just donated the proton, so we still need to fill in those electrons here and give that oxygen a negative charge. I hope this video helped. The next video will be covering conjugate acids. If you need any help clarifying or anything, or if I made a mistake anywhere, please let me know and I'll fix it.